Starting. Okay, recording. Cool. So quickly, just introduction to the app that is now. It's a very simple app that I did like a long while back with just authentication for a demo. Very simple Express server using MongoDB. So Mongoose Connect to just actually connect to it, and then running the Express and just going through the whole thing, getting the ports and all, and very simple, nothing complicated. We're gonna buff this up to include WebSockets, which I'll explain briefly after this, and then we'll sort of dive right into the code. So let's go, I guess, get into it. So quickly, WebSockets, just want to highlight what it kind of is. Usually if your typical backend, the one that I showed you right now, you have your backend, your front end, they're very separated. What you usually do is you create a set of routes for your API to connect to it. So your front end, you'll have a user action, sends your request to your backend, and then on the specific endpoint, then you'll just update the DB, and then you'll send back a response, whether error or successful or any of that, and you'll get an update on the user interface. This works for most use cases, but you get into some slight errors, especially when you have multiple users sharing the same source of information. This is particularly obvious in like chat, like you want to have the same updates on the screen at the same time. You don't have to refresh your screen to get an update. You can see the problem is I send my request and I get a response here, but there's no reason for the front-end user to get any information because there's no connection right now. So that's kind of the problem. So what we do is we introduce something called WebSocket, which is we're using Socket.io, which is the sort of JavaScript version of it, but it makes a connectivity between the front end and the back end that's always there to just kind of listen. And this is quite important because you'll see in the different use cases. For a normal, let's say, simple request, the user still does an action. It goes back to the back end. He still can get a response. But when we get a confirmation response, we send out another request to say whether it succeeds or fails or any sort of emit that we like, which is a socket term, just to emit some sort of action. And then the socket will receive the update, and then it'll update to all the connections that are related to that. And so in this particular user, since he's already got the update of the user interface because he was the one that triggered the response, there shouldn't be any change. But that's important when you have two users, because you can see here, for the second user here, he will get an update. So it's the same sequence of actions: request, response, that emits the successful or fail, and it'll go up, and then the response will go up because he has a listening sort of channel open. So this user will also see whatever updates have come. So this is how you keep it all synced within it, and that's the reason why you use WebSockets. And for this implementation, we're using Socket.io. Socket.io, JavaScript version of it. You can go through its website. It has a lot of documentation on how it works, but they also explain kind of a lot of similar things that I just mentioned. So with that, let's just jump right into it. Here is your baseline code. Very straightforward. You have your server, as I mentioned earlier. We're going to sort of buff it up a little bit to sort of support the WebSocket stuff. The very first thing is I'm not going to actually use a normal app listen. I'm going to just introduce a HTTP element, which will then give us this. Actually, I can copy and paste some of this. That might be better. So HTTP, this will just change. Instead of running the server directly, we're going to create a server instance using HTTP, using the Express details. So that's the slight change here. And what that will do then is we can just run the server instead of the app when we're running the starting of the instance. So it's the same thing, but what this also lets us do is we get to use the server instance for a few other things, which is important for WebSocket and also potentially other middlewares. So I'm just going to quickly start up this. Inside this instance also I have Docker Compose to run your MongoDB. This is just a simple way to start a MongoDB using Docker. So let's just, I don't think I'll cover this now, probably in another time. Docker Compose up. So it's just starting an instance of MongoDB so that I can run that. Let's open a new terminal. Now that MongoDB is running, if we look at our backend code, you can see here that, yeah, we're going to connect, so it shouldn't be any problems. Earlier we would have had an error. So let's go with node index.js. So we're running, this is server.js, sorry. Server.js. So we're running the instance now. Alright, so it's connected, no problems, it went through, and instead of running the app directly from Express, we're using this HTTP to create the server and then do the same. So now I'm just going to copy and paste some code that is kind of important for this. So let's just add the WebSocket, the original thing, inside. So here we have socket.io. We are introducing it by installing a package called socket.io. So if you hadn't installed it, you'd run your npm install socket.io just on node and run through. It should be, again, I installed mine, so it shouldn't take too much time. I'll just run through my code. Yeah, this just tests. So then we start that again. So now we have socket implemented. Just make that look nice. Okay, so within the socket now, we have to start adding in, even though we've created this socket interface, we are not actually listening for anything. It does exist, and how this works is it takes this, this socket.io has this setup where you'll take a server, which is this current server we created, and you pass some objects, parameters within it. For this, all we're doing is passing a cores, which is going to tell us the origin is from the port 3000. This is to block, to prevent it from being blocked by your Google's or your browser's cross-origin policy. So whatever your front end is going to be, you'll just pass that inside there. So again, here we're running a React on port 3000. Later you'll see it. So we sort of have it very simply just like that. The next thing we're going to add in is a connection instance. So when a new connection happens, we just want to be informed of that. So on a connection, let's close the bracket. Here we're going to have this slight something to just kind of let us know that the instance has occurred. You can actually go through the documentation for this, but socket.io has this off and then the slash, so it's just telling you all of the base connections. I'm getting all the sockets, and I just want to get the size to tell me how many users are connected at any given time. So anytime a new user comes up, it'll just tell me the total user count at that point in time. Another thing we want to just put inside is once we have a connection, so how socket works is you create a layer, which is your connection layer, and then within that connection you can add a bunch of commands that are related to that connection specifically. So on this connection, I'm adding in this for the socket element. Again, just now I checked, I was just putting in the total number of users. Now I'm actually using the socket element that's created on this specific connection to create a sort of a disconnect trigger. So when a user actually disconnects, I want to emit this or let me know that there's somebody that's left. So with this already, we have enough to sort of start. Let's go to the front end. So on the front end side of this, I just put in a simple, very simple React app. So I just put it inside the same folder so that I had a single file. So here we just run npm start. Let it load. Give it a second. Any questions so far on that? I think it's a bit fast, but if anybody is stuck anywhere, just let me know. I know it's a lot of info. Okay, all right.
Well, one question.
Yeah.
So with the HTTP, you click a new server again, right? Is there like the method that we have, the conversion that we have to follow, or is that we can use other methods to create another server? Or example, like we wrap our entire backend server with the socket.
You could use, yeah, so you can use HTTP as the default by node. You can use something else. The other one, if you wanted to use a HTTPS, you can also use that. If you want to serve on HTTPS. You can also create a server using HTTPS. If you have any other instance way of doing it, you can as well. You just have to pass that server instance into the socket.io. Yeah. So, alright, so let's go on to the front end. So I just loaded this front end. It's a page I created a while back. Not much on it, just registration to create an account, a username, and a login. I didn't put anything much to this. There's no focus on it. But when we log on to it, I wanted to, oh no, I actually had something called protected paths. So I kept this protected path route, which is just a protected page. This was like something, a demo from a long while back. But anyway, the point of that is just so that we have an app to sort of test this all on out. So here we have the protected page. I want to just copy in some code that I sort of prepared on this protected page. One thing is I just want to add a form to this instead. So I'm just going to copy the whole form that I made. So I'm just creating a form, And I'm just going to add the constants at the top first, and then we can work with it later so that at least it doesn't break. Oh, and then the functions are going to just be a problem. Alright, let's add the blank functions for now. Constant join room equals, let's do an arrow function, blank one, and the other one is, I got join room and send message. And we'll add all these details in later. I'll explain why. Alright, so, and I just need to bring in the imports. Alright, cool. So that should work now. Load the page, use state, of course. The first thing is use state. Alright, there we go. So now we just have a form. I just created a form. It doesn't do anything yet. It's just to give a username and to join a room. And the reason I want to do is just for the demo, I want to create a very simple chat room so that you can see a direct use case of how this would work. What we haven't done yet is we haven't really brought in the actual WebSocket implementation. So usually you can just create a new folder anywhere, but I'm just going to create a new file in the util folder. And I'm just going to call it websocket.js. And within that, there's a line of code that you just need to run, which is this import of IO from the socket IO client. So this is the front-end client for it. Actually, if you want to really read about it, there's two sides to this. It's the client API and the server API. You can also just see the setup if you're stuck anywhere for a new instance. All is in the documentation. And if you go through it, they actually do have a highlight of it. You can also see how to set it up. As well as if you follow here the resources, they have, in the learn, under get started, they also will show you the steps of how to do it with just the initial implementation. So it's very clear there, so I don't think I want to go through it in too much details. So here, you're creating a whole socket concept. So the socket is come up on the front end, and we are telling it where the back end is. So here the server is local, is the port 5000, because when we ran our server earlier, we ran it on port 5000. So you're just pointing it to your backend. If this is an API somewhere or anything, you just have to point it to where exactly your server is going to be hosted so that you can communicate between the two. So this is the essentially everything you need to create the connection. It's very straightforward. From there, we kind of have to just import the socket. So we can just go to the app.js file and we just run it here. So it's in the utils folder and then WebSocket. When we've done this now, it's actually saved it to the front end. So we have the socket running, that is everything there. If we go to the back end, so if we run our server, so I have to rerun it, you can see that a user has connected, and I get it as one user has been put inside because I have one browser open here with one connection. If I open an incognito tab and I do the same thing, connect another one, so localhost 3000, it will tell me that a second user has connected. So here, as many users as connect, it will be telling me, because in the code earlier, we already put a little note there. Whenever a connection occurs, just to correctly calculate the number of users that are currently connected. So the same thing happens when you disconnect. So I created this this incognito. So if I closed it, because that terminates the connection, we see a user disconnected. I could again put in the count, but again, not a bit redundant. So whenever a person comes in, we'll just see the updated number of user count. So that's the whole setup of actually connecting the two. So we've actually created the channel that I talked about earlier. So we've sort of done step one here of the slide. So we've just done up to here. We've really just made the two listening between the two. We've connected the server for the front end and the back end. We haven't created any of the emits yet, which is what we're going to do next. But before I proceed, anything you want to ask anybody?
A small question about the connection. So you put over there that your socket io.off is to the root path, right? Does that mean that you can just put that to any path, and whenever somebody connects to whatever path, that will tell you the size?
Yeah, so you don't have to always connect on the root. I haven't explored fully all of those different connection methods, but it's inside the documentation if you really want to read through it. I haven't seen a use case yet, but probably be interesting to see as well. Awesome. Anything else? All right. So we'll sort of jump into now the sort of the emits portion of it. So everything before was just making a connection. Now we want to actually say how it works, because you don't want to always emit connections to everybody, because let's say you have 1,000 users, you don't want every update on every single page to affect each user. So sockets have this concept of rooms. So you want to be in a valid room. So take chat, for example. If you're in a specific chat room, you want to see the updates to that chat, but you don't care about all the other chats. Can you imagine if your WhatsApp got every update from every chat that's happening all the time? It wouldn't make sense. You'd kind of like crash your phone, the servers will go wild. So we specify a connection to make it a bit more efficient. So in order to do that, you create this concept of a room. On Socket, they call it literally a room. And what you'll have to do is write this string, which is let me actually copy the whole thing and explain what it is. So within your connection now, we have one is just logging. That one's to tell us when a disconnect occurs, which is a standard setup. Now I'm adding a new one. When somebody does this join room, which I'm defining. So how this works. So socket on is very interesting. So actually, if we just write it out, let's just show you kind of what it does. Dot on. So it gives you, I think if you read through the process, you just define an event string. So this is a listener that you want to explain. So you can call it whatever you want. You can call it test. You can call it the football, whatever you want to name your string. It's just an identifier for this specific event. And then after that, what you can do is you can have a callback function that will run. So within this, the first one that we're creating is join room. It's literally just to tell us that somebody is joining a room. So this one has to be a listener. So you need something to trigger this request to join the room. So that actually sits on the front end side. So when we go to the app, I think the protected page, I started looking into it, but I didn't really develop it. I created a simple form, and within that form, it was just a username and a button to join the room. But we didn't add anything to it. So now I'm just going to add some code there. So the join room function, I created it to be on submit when we run this first username function here. So here within this, we have the join room, we have a button to do the submit, and it's running the join room on submit. So quickly, I'll just copy that code again over. So I had the join room function here. So here, I just prevent default behavior for the form because I don't want that to happen. And I add this socket emit. So because I want to use socket, I have to import it from the relevant file. Again, it's in the utils folder. So I go back one file to the root, and I go into the utils folder, and I go to WebSocket. So I'm getting the socket file, socket, I guess, implementation, and I'm running the .emit. If you ever want to also go through it, you just do socket dot, and you do your control space bar on your Visual Studio Code or your code editor of choice. You'll actually see all of the different options that are available. So there's emit, connect, there's a few other things that you can do. I won't go through all of it because it'll take, I think, way too much time, but let's just start with a basic use case of emitting. So within the emitting, it's just like it's like a loudspeaker. You're shouting out to everyone that this thing is occurring. So it's to tell your backend that something like this is occurring. So for this use case, I'm just passing in the username value so that we have a username value for that person, and the join room command. You could even pass in other details. I think if you want to look at a more complicated setup, you might have, instead of just one room, you might have multiple rooms, like again, many different WhatsApp calls and all those other potential use cases. But in ours, for testing, I'm just going to create a single room that's available on our server. And that's why if we go to the backend now, under the listening for the join room, I'm just going to console log the data to see the name of the person that's trying to connect. Then I'm going to see, I'm going to actually do this socket join. So socket join is to create and join this specific room. And then what you have to do is you have to provide it a value for that room. So if this was an ID, if you had like unique IDs for each room and you saved it somewhere like a WhatsApp group chat or something, you would ask to join that specific WhatsApp group chat. But in this case, I'm just going to have test room. So you're going to join this test room, and it's going to just say, okay, if that happens, just send back a response. That's the whole implementation. So from the front end, right now, you can join the room. So if we go there, I'll just also run through the code quickly what I did as well. I added this join flag just so that I can say that once I've joined the room, I will show the message options instead of the username and join room option. So it's just a small code thing. So right now, if I write test user, and I submit that. Alright, let's see. Why did I get an error? I've been blocked by the core's origin policy. 3000. Alright, I tested this out earlier and it's not working now. Why is it not working? 1 second. This is odd. Localhost 3000. Why is there cross origin error? Why is my server's not working? Okay, sorry, my front end seems to have disconnected. It's not letting me refresh. Okay, let's just restart that. Sorry, any questions while it's waiting so far?
So I saw that in the test room you just join it in the backend, right? So we don't manually need to create a room for it, right? So once...
Carry on?
Yeah, so once it's not exit, it will just create itself, right?
The room, yeah, you'll create it if it doesn't exist. If the room already exists in that specific, like if you try to join a room that exists, you'll join an existing room. If it doesn't exist, it will create a new one. So you don't have to specifically create it, you're correct. Alright, that was very odd. Okay, let's just put a login again. I don't know why I had an error just now. Okay. One user is connected, so let's try this out. Why is my code not working this time? Okay, let's just see what is the issue here. That page. Just going over the full working code. WebSocket was localhost 5000, and that one again was localhost 5000. Alright. Okay, might have typed something wrong. Okay, there we go, it's working now. So I just changed the code. So let's just go back to the server.js. Join. Alright, let's go back to join room. So join the test room. Let's see if that works. On the front end, I think we don't need to change much. Okay, sorry about that. And test room. Test. Okay, so it was something wrong with how I wrote the front end just now. Alright, going back to the thing. Alright, so when we do the join room, I think, alright, let me go back to look at the thing. I've added in the full code with everything inside, but let's just focus it on part by part. So on the join room, I'm emitting this join room. I'm passing in the username value, which I type in into the input form, and that will go to the backend. And then if there's any error, it will return an error. Otherwise, it'll set the join flag to be equals to true, and it will display the messaging option instead. So for here, again, so let's say test user. I created a test user to connect to the room. And now you can see that the test user has come to the backend, because within the request for it, I actually included to just log the data, and then I connected to the room. So I connected to the test room. So now this user is actually connected to that room. We can start looking at adding different features to it, because now he's just in the room and there's nothing there. We need to start being able to send messages or send data. In this case, if we were going to interact with the backend for any other code, or any other updates to the database, we'd want to be able to send some sort of request from the front end. that will come to this backend, and then anyone that's inside of this room, so if there's multiple users, so for here, if we connect another user, we can also do the same. If he was also connected, how would we interact between the two? Alright, let's go. Let's put in protected paths. Okay. What is my... Okay, let's just create a username. Oh, actually, I think I created a username called door. Yeah, okay, I did. Alright, / protected path. Okay, so this is a different user. So let's say he was the door user. If he joins as well, he's gone to the message section. And you also can see that door has joined the room because I console logged this data here. Okay, so now we've already connected to the room. We want to be able to chat. So the next part is to be able to send this message. So on the front end, now for a specific user, I add in this message option to send a message, right? So since we've already got the join the room, we can actually send a message to that specific room because we're already inside this room. So whenever I click the send message option, this button here, I created the input for it. Again, very simple input form. You just take whatever input here, you update it, and then you can click send message. So if there's a message, I will send an emit request to the send message option. And this time I want to pass in the message and the username straight away, because we already have the username from earlier, and then we want to pass the message as well, so we can nicely display that. So to display it, I just did a quick list group item where I filter through a list and I show the username of the person plus the message. And I update that every time you receive a message, but we'll get to this portion after. That's not very valid yet. So when we send a message, we're just sending this message plus the username to the backend. So we can see how that works as long as we create a listener on the backend side. Let's minimize that and go to the server side. So now we need to add in a line to just connect to the actual send message. So within the send message, before, also under the same connection, you have to add in the send message option, all within the same connection. Because if you put it outside the connection, it won't actually hear it. Because this is all part of one user connection, the user connection that we've created in that listening channel. So here, socket on send message, I'm just waiting to for any response that comes inside with the send message request. And what I'm doing is I'm going to send a message. So socket has this to command, and you can send it to a specific room. So before anyone that's joined this test room, since I send it to this test room, it's going to emit this whole message with the data to everybody that's joined into this test room. So I'm getting the data from the send message request, which is sent from the front end, because I send the data in this response, and this is the syntax. When you do an emit, you can pass in first the listener. So this is the send message. This is what I'm listening for, the data, and then a callback function. So here the callback function, I'm just checking if there's an error, and then it's just returning a console log for the error. If it's successful, I don't do anything else. So here, I send a message and the username. So expected here in this data, I'm going to receive the message and the username. All I'm doing is emitting to this message. So now I'm creating a message. So I need a listener on the front end to receive this message with the data. So that's the last part, sort of to close this whole thing up. You can see on the socket, first thing I do is, because I'm putting this on the flat page of the React app, it will be run every time. So if I don't actually do this command, which is off any, this basically will close all the previous connections of this message and then create a new one. And the reason I do that is purely because every time React does a new rendering, it will actually run this whole command, right? Technically, if you wanted to do this properly, you'd use a proper use effect, put it into place and all that stuff, but I was just doing it very quickly. So I just wanted it to be whenever a new rendering happens, it will turn off the old message listener and just create a new message listener. That's the only thing that's happening here. Again, it's sort of more of a workaround than anything else, but it's also good practice sometimes to have this, even if you're not continuously rendering the thing, because sometimes for whatever reason, maybe your React page had a double render that triggered the use effect very quickly, or whatever the case, it still prevents you from having multiple channels open. What happens when you have multiple channels open to listen is you might just get double messages. So every time a message happens, because you have two event listeners, it will get two responses. So you just want to avoid that by adding the socket off any. So I'll just close any existing message and start a new one. So now I have a listener for on message. All I'm doing is setting a message. I'm taking the new message that comes in from the response, because here when I set the on, I'm putting a listen. For a listen, what you have is the event, and then you have the function that will be the callback function, the application function when you hear this or you get a response from this message. So here I am just taking the data, and all I'm doing is putting it in the first position, and then I'm adding all the existing messages after it. That way, when I do these messages, all it's going to do is to add to the top of the existing messages the new message, and all the old messages will get pushed downwards. So very simple implementation. So if we save that, now on the server side, we'll see that when I get a send message, I'm going to emit it to all of the test rooms. You can actually, before we emit it, let's just do a console here to test out the different phases of it. So let's not actually do the emit first. We're just going to console out the data to see that we actually get the response for the send message. So now on the front end, let's connect as door, for example, and I do test. So when I send a message, the message has gone. Okay, I got console log for the user. Why did my message come in? Test message. Oh, I didn't restart. That's why. Okay, sorry, I didn't restart my backend. I'm not using NodeMon. My bad. Okay, so the backend is restarted. So let's try that again. So when I send a test message now, okay, so you can see that the request actually comes in with a test message. So now the last part to sort of close it up is just to emit it. Because you actually saw that I didn't get a response here to show the updated message because I didn't actually emit it. So the backend is hearing it. It's getting the request, but now I just have to tell it to do the final step, which is to add it to the test room. So that last step there, let's refresh the whole thing, and then let's restart the backend. Alright, so now I'm going as a test user, for example. So I join the room and I send a test message. And we can see that the test user has sent a test message. So this, in the use case of sitting in a single page, doesn't make a lot of sense. Where it becomes very useful is when you have two instances open, right? So you go back to here, I log in again. Protected path. Alright, so now I log in as door. I join the room. The thing is here, because I didn't save the messages in a database anywhere, I can't see the history. If you were doing this again in a proper implementation, you would actually have a history of it potentially to be gotten from your database. But here it will still get all the real-time messages. Hello test user. So here, all the messages I put inside will come in straight away in real time to this guy as well. Hi there. Yeah, slightly delayed, just lags on my side, but if you have your server running and it's quick, it'll just get all your messages straight away. And also I think one of the reasons it's a bit slow is my implementation to do this on the front end, this on and off every time is probably also causing a bit of a lag. So you would probably put in a use effect for a more effective, to be done right. But yeah, that's the whole thing. You can see what we actually really did. It's very simple what we achieved. We actually have just made a very simple chat. The data doesn't get saved because we didn't actually create a backend database to store all of the data. So every time you create a new chat room, it will start off as a blank room, and then any messages that come in will just come up. Yeah. So you can create a basic chat. So that's going back to the slides, just to sort of cover what we did there. That's here, right? So let's look at that. So we've done this whole portion, and now we can see that both of them are getting the updates. So when I update on front-end user 1, he gets his updates as well, because the emit will respond to him. But this front-end user 2 will also get it. So the more users you can have 3, 4, 5, 6 users. As long as they're connected to the same room, they'll get all of the same updates. So that's the entire implementation of Socket from really like the simplest version. As I said, there's a lot more to it. If you really want to go through it, the full documentation has a hell of a lot more information. It's highly interesting. I think it's worth exploring for any app, because you can, if you really think about it, the use cases are kind of endless. You create this real-time option to communicate, right? Even in their own, they show it in the concept of like blogs like this. So when you're doing tweets, you want to get all the update of the latest tweets. I'm sure you can think real-time data. There's a lot of reasons to have real-time data for your dashboards. There's many different ways you can use this socket implementation. The main thing is just getting creative with how you use the emits of requests and then where you're going to hear the responses from. So that's it really from my side. Any questions? I know that was a lot of info, but you can ask any questions you have, otherwise we can finish early.
No.
Everybody understands sockets and their basic implementation?
Yeah.
Confident they can.
It was pretty clear still.
What's that?
It was pretty clear still.
Okay.
No questions.
Cool. Well, then I guess I'll leave you guys to it. Thanks for your time. It's literally just an introduction to it. I hope you all can go and explore that a little bit more. And we'll do more. We'll see how we can expand this even further. I think I touched very briefly on Docker Compose there, which I think will probably be what I next go over, because I think it's super interesting. But it'll be for Linux, not for Windows. So a bit in that sense, because most servers actually run on Linux these days. Even Microsoft now has introduced their own Linux because they can't compete. Alright guys, thanks for your time. Have a good day and ciao.
Yeah, bye.